The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. This is Michael Deru from the National Renewable Energy Lab, and welcome to the Better Building Space Conditioning Technology team call. We're going to talk about several things today. I think there'll be some more people joining, but we'll just jump right in right now. So we have all right, here's our agenda for the day. We'll just talk about some introductions, some updates on the research team, and then I don't have it on here, but I'm going to talk about some of the new technologies that were available at the recent AHR Expo and some of the winners, and then we're going to specifically highlight Inverid today. It's an air cleaning technology that was one of the award winners. And my name is, as I said, Michael Deru. You can see my picture. We have Marwa Zartari from Inverid to talk about their technology. And then I'll also talk about some field validation results that we did. Also pictured here is Miles Hayes. He's new to the NREL team and will be joining the HVAC research team and will actually be your main point of contact starting in April, as I'll be moving to another position working directly with DOE. And I'll still be around and happy to answer questions, so please always feel free to email me and ask me questions. But you will be interacting with Miles along the way. So then we'll have some Q&A at the end and some discussion of results. All right, first off, the Better Building Summit. July 10th and 11th in Arlington, Virginia. It's moving back to Washington, D.C. area this year after last year in Cleveland. And again, this year it's just the Better Building Summit. It will not be combined with the Energy Exchange conference this year. So please go to that website and check it out, and you can register today for it. So it'll be an exciting summit again this year. Some updates. So the Advanced RTU Campaign Recognition Awards, we are processing all of the awesome awards right now and we'll be announcing the winners of the recognition awards at the PRISM National Conference April 30th in Denver, Colorado. So that'll be exciting. New reports from GSA Proving Grounds are related to HVAC technologies. There's several cooling tower water treatment technologies. I think 5 different technologies covered in 3 different reports. High efficiency circulator pumps. So these are small fractional horsepower pumps, but very high efficiency and a lot of intelligence built into those pumps. Some pretty incredible performance there. High efficiency rooftop unit report and a high efficiency chiller report that's available. So I was going to put the URL here for this, but it's super long. So just go ahead and Google GSA Proving Grounds and you'll find them. All right, then reports that are coming soon. We have several reports that are from field validation projects that are in various stages of completion, but they're all very near completion. We have high efficiency smart motors that were used for refrigeration condenser fans. RTU automated fault detection and diagnostics landscaping study. We have the Inverid gas air cleaner technology report that's coming out, and chemical-free cooling tower water treatment technology, and that also will be coming out soon. All right, and then new and ongoing projects. We have a continuation of the RTU AFDD. We're going to actually be collecting performance data and processing that and understanding how those systems perform and what kind of value streams you can get by including AFDD with the RTUs. And then we have a new project looking at coordinated control of RTUs. So just instead of just having individual control of RTUs, but controlling a whole rooftop of RTUs. So you can optimize energy and demand and delivered performance to the space. All right, want to bring up again the RTU, the HVAC resource map. We're going to be adding some new content soon, so watch out for that. We'll let you know when that's when the new content are available. But it's a great resource, and always let us know if you have any comments or questions. All right, so the AHR Expo is an annual expo. This is the world's largest expo for air conditioning, heating, and refrigeration technologies. It happens January every year. This year it was in Atlanta. There were over 45,000 attendees and 1,800 exhibiting companies. You can check it all out at that website. But I want to kind of highlight some of the award winners this year. There were some really great technologies, some pretty cool stuff. Automated Logic won for building automation for their OptiFlex virtual integrator. It provides a simple data aggregation and monitoring across diverse building loads. And so that's you can go, if you go to the AHR Expo website, you can find more information about these different technologies, or you can go directly to the company's website as well. All right, Johnson Controls. You know, there's a lot of magnetic bearing centrifugal chillers out there, but this is the first one with an HFO refrigerant. And so the really cool thing about that is it has a global warming potential of 1. So instead of using, you know, HFCs that have global warming potentials in the thousands, there's a global warming potential of 1. This is really exciting for, you know, for chillers. So check that out. Next, we have, let me get my control back here. In the heating category, Gentech has a new EC motor for furnaces. So it's these are, you know, small, relatively small motors, not, you know, in the one that I think probably 1/2 to 3 horsepower or so motors for furnaces, but they're electronically commutated motors for high efficiency and variable speed operation. Indoor air quality, CPS products introduced their IAQ Smart Air monitoring system. And so this is mainly for technicians and facility staff to monitor air quality, and they have a pretty good website or tools to do that. In the plumbing, not too exciting, but really easy copper press fittings and coupling systems, so you don't have to braze copper fittings. Makes it super fast, and you don't have to worry about having the brazing and the flames. All right, onward. Emerson won the refrigeration for their introduction of their Copeland scroll fractional horsepower motors. So these are for refrigeration now. This is not for air conditioning. So they go low temperature compressors across multiple gases, and this is in the I think 3/4 to 1.5 horsepower motors. So this is mainly for like refrigerated cases and so on. Software, Takeo Comfort Solutions for their cloud-based tags software for their, so Takeo makes, if you're not familiar with them, they make pumps, and they have a really cool software for monitoring their pumps and the performance of their pumps. If you're worried about hydronic balancing of systems, Dwyer has a great wireless kit for balancing your hydronic systems. All right, so back to more hardware stuff that I'm interested in. Energy Wall. This is a really cool, I think, energy recovery ventilation system. It's modular, which makes it very flexible. So they built in a lot of features into these modular units, and because it's modular, it's expandable, so you can go from I think I forget what the CFM is per module, but you know, like 1,000 CFM up to several thousand by just adding these different modules. And each module has a ECM motor, has a bypass, which is very important, I think, for so that you can bypass ERV and avoid the pressure penalty when you don't want to ventilate, or when you want to ventilate but not energy recover. So that's a big deal. And then these are solid. I think they're a ceramic membrane ERV, so they're very effective for latent and sensible heat recovery. Check it out. I think it's going to be great. And then green building winner was Inverid for their HVAC load reduction, or HLR indoor air scrubber. And the most exciting part, so that's all. So at the AHR Expo, all of these awards that I just announced, they're actually announced ahead of time. And then at the show itself, they announced the overall winner and for the product of the year. And so Inverid also won product of the year, which is very exciting. So of all the products that were entered at the AHR Expo, Inverid won the overall product of the year. So we're really excited for that. And so now I'm going to turn it over to Marwa to speak about Inverid and the HLR technology. So go ahead, Marwa.
Thank you, Michael, and thank you for this opportunity. So I'm the Vice President of Building Solutions at Inverid Systems. The company was founded in 2010, and I've been with the company almost 5 years. Can you go to the next slide? So the mission of the company is to improve energy efficiency while maintaining at least indoor air quality, and most of the time we offer improvement in the indoor air quality. We focus on commercial, education, and government buildings so far with our technology. We are headquarters in Boston, Massachusetts, but we also have offices in China and the Middle East. The main technology we have is sorbent materials. But also in our solution, we also have electronics, controls, software, sensors, and monitoring capabilities. The solution that we present is mainly an energy saving solution, and it's compliant with ASHRAE standards, mainly ASHRAE standard 62.1, which is a standard ventilation for acceptable indoor air quality for commercial buildings. And also we're compliant with the International Mechanical Code and green rating systems such as USGBC or WELL. Next slide. So from the beginning, we seek to work with clients, with high-profile clients and names, to build our profile of case studies and be backed by these big names. So we focus at the beginning of our journey on retrofit projects, and to build basic case studies to basically prove the technology, prove the energy savings, and prove the indoor air quality. So Michael later will talk about the project we did with DOE and the National Renewable Energy Lab, picking few buildings and doing the demonstration. Our latest project is with Harvard University. We implemented our technology in 2 buildings. And then we received a grant from Massachusetts Department of Energy Resources, and now we are gearing to deploy the technology as retrofit on 12 more buildings. So besides retrofits, a year and a half ago, we start also adding plan and spec, so new construction buildings, and I will show you later what is the benefit for that to our portfolio as well. Next slide, please. We also, throughout this, we obtained support and endorsement from different utilities and for example, from Department of Energy and DOER, and utilities for amount of rebates that will help both in retrofit and plan and spec. And these rebates are basically can be up to 70% of the cost of the project. and they are based on dollar per kilowatt hour saves or dollar per kilowatt or for gas or steam, depending on which utility it is. Next slide, please. So what are the challenges we are solving? The first challenge is ventilation. So currently, most of engineers use ventilation as a solution to pollution. You might have heard that dilution is a solution of pollution. So the problem is that you bring air from outside that's hot and humid or maybe cold, and you need to condition it before you put it inside. So typically your air is replaced 1 to 2 times per hour. However, dilution is not good a solution because of its impact on energy. First, from HVAC capacity. So for new construction building, you need to size your system to be able to deal with all the amount of ventilation that you need. Second, it impacts your ongoing energy and water consumption and impacts your maintenance. But the other thing as well is outside air is also polluted. Can you go to the next slide, please? So as you know, fresh air is not fresh anymore, especially in dense cities. And you can go to the different websites, different monitoring station, or the EPA website to find if you are located in attainment or non-attainment area. And the problem, you might have particulate pollution or ozone or other contaminants such as carbon monoxide, NOx, SOx, etc. And some of these pollutants you cannot even clean. So you end up bringing outdoor generated pollutants from outdoors to the indoors that worsen your indoor air quality. Next slide, please. So beside the energy efficiency challenge and the outdoor air quality challenge, there is also the indoor air quality challenge. So you might have heard this before. People spend more than 90% of their time indoors, and we are designing buildings for occupants. So there are a lot of literature review that document for offices, schools, that if you occupy the building and the building has low contaminants concentrations, you will be more productive and you report less health symptoms, basically. So it's very well documented. But I'm going to highlight in this call one newish research from Harvard Public School of Health. They published in 2015. Basically, what they did is that they brought occupants in office spaces, and they divided them into 2 different environments. And they subjected them to different pollutant concentrations. So, for example, one time they lowered the amount of carbon dioxide, and then they repeated with moderate carbon dioxide and then elevated carbon dioxide. And they did the same with volatile organic compounds. Can you click, please? So as we expected, and which correlates with all the literature before, when people were subjected to low concentrations, they were more comfortable, they perceived the space better, and they scored better on cognitive functions. Can you click? But the new the new finding is that carbon dioxide is not only an indicator for ventilation, it's actually a pollutant that have a direct and negative effect on productivity. So when they went from low CO2 to high CO2, people scored lower on cognitive function. So the study concluded that, carbon dioxide is a pollutant and we need to control for it. And they went one step further, which is something we don't usually do, is they monetized indoor air quality gain. So they said they came up with this number, $6,500 per year per employee, if your employees are in a space where you have lower concentration. And that's kind of new, and I believe more and more research will monetize indoor air quality, because usually when you sell a solution, you sell it based on energy savings, which is very easy quantified, but selling it based on indoor air quality is harder and harder to quantify. Next slide, please. So the embedded technology is solving these 3 challenges, energy saving, outdoor air quality, and indoor air quality, by using a performance-based approach of indoor air quality procedure documented in ASHRAE Standard 62.1 plus air cleaning. So what does it mean? It means we are implementing air cleaning as an energy efficiency measure. So less ventilation is needed to maintain the same acceptable indoor air quality. So you implement both dilution, so less dilution you need, plus air cleaning, and you maintain the same indoor air quality. So one indirect benefit is when you do that, you decrease the intake of outdoor generated pollutants indoors. So how we implement this solution? We take a part of the return air stream. It can be a plenum or it can be ducted. We clean it and we put it back into the return air. So we're not cleaning outdoor air, we're cleaning only return air. And doing so, basically, we can decrease outside air as much as between 60 to 80% while keeping, of course, the building positively pressurized and employing these HLR, stands for HVAC load reduction modules. Next slide, please. So before I talked about how the system works or what's inside the system, I want to tell you about the most use cases for this technology. So the first one is in plan and spec, so new construction buildings where we want to decrease the HVAC capacity and save on first cost of the project. Also in basic climates where it's very hot and humid or very cold, when you want also to save on ongoing operation cost. One use case is where you have a change of purpose of the space. So let's say you had an office and you suddenly adding occupants. Maybe you transforming the office to a WeWork type of space or call center. So in this case, you have two solutions. One of them is you need to retrofit your building and rip off your existing DOASs or air handling units and add capacity. Or alternatively, you say, this is how much outside air I have currently, and I supplement the rest of the outside air needed by air cleaning. This is also very similar if you have a project with certain like energy efficiency requirement, or it's a geothermal project, and you cannot drill more wells, you substitute the rest of ventilation with air cleaning. And you can see the rest of the use cases. Basically, if you have projects and you lost capacity on your cooling, or you have humidity issues because of that, you can supplement the rest with air cleaning and still be compliant and still maintain the same acceptable indoor air quality. Next slide, please. Now, I want to talk to you in a few slides about what is inside the HLR and then how does it operate. Next slide, please. So we have two models. One model for we call it M for mechanical. So it can be indoors. Usually it's in mechanical room, or it can be in the space directly. It can be plenum or ducted. So if you have a plenum room, the HLR can sit inside the plenum and just clean the return air. Or ducted, it can take from the return air duct and put back into the return air duct. So you see in the middle, we have the sorbent cartridges. There is 12 sorbent cartridges in this module, and they are located in V shape. We have a heater underneath the sorbent and then fans. And I explain later why we need the heater, but the fans basically are there to ensure that you don't add any pressure drop to your system. So the fans are capable to take the air from point A to point B. So the inlet for this device are on the vertical on the right side, where the sensors are located on the right side, and then the outlet is on top of the unit. And we have the controls board and sensors. Next slide, please. We have an outdoor version. Typically, it's on the roof, so we call it the HLR 1000R, R for roof. It's the same concept. You have fans, heaters, sorbent cartridges, and a set of dampers. It takes air from inside, from the rooftop unit, basically, or from inside the building, clean it, and put it back into the return air stream. Next slide, please. So how does it work? The HLR has two modes. The first mode is adsorption. So adsorption of contaminants, you get to indoor air, you get through the fans are working, it goes through the sorbent and goes back through the green damper on top to the air handling unit, return duct or plenum. What does it capture? It captures carbon dioxide, and this is the main forte of the technology, formaldehyde, also the main differentiator of the technology, and also VOCs, ozone. It does remove odors, and it has zero byproducts. The technology is not new. The technology has been, used widely in submarines. I don't know if you watch Apollo 13, submarines and space shuttles. And one module approximately can take care of 15,000 to 25,000 square foot of space. Next slide, please. The other differentiator of the technology is this mode. It's called regeneration mode, heat and release. So what happens is because you are sorbing carbon dioxide at parts per million level, you need to clean the sorbent. And we do clean the sorbent every day when the equipment works. So when you need, when you need to close your outside damper to a minimum, when you need to have savings, basically in mechanical cooling or heating, the HLR will come on, it will do cleaning during the day, and then at night, it will do this mechanism we call regeneration, which is a cleaning. And this is where we spend a lot of effort in re-engineering the material in order to do regeneration at temperatures that are suitable to buildings. So once per night, we get indoor air from inside, and we turn on the heaters, the fan and the heaters, and then we heat the sorbent. And once we heat it to a certain temperature, which is 130 Fahrenheit, it excites basically the MOCO, and only then you have regeneration. And we hook this system to the building exhaust. It can be toilet, it can directly to the outside, in order to remove what we sorb during the day. And this allows us every day to start with the same efficiency for the sorbent. Next slide, please. So the sorbent is equipped with sensors. You can see on the right-hand side, we have a temperature, humidity, carbon dioxide, and TVOC, total volatile organic compound. And this will measure the inlet, so what's coming to the unit. And this later you will see it will be displayed to the client 24/7. Now on the outlet, we have temperature, humidity, and carbon dioxide. We also have temperature sensors and pressure sensors inside the unit. Now we have ability to do backnet or hardwire. And so we receive signal for the equipment to work, we receive the fire signal, and then we send signals back regarding the air quality, regarding energy savings, and the status of the unit. Also, we have cellular connection that basically we receive the data through our embedded cloud for monitoring and for alarms. Next slide, please. I wanted to put this picture to give you an idea about our dashboard. So basically for each building, for each air handling unit, for each HLR, you can see the status, you can see energy savings, you can see the outside temperature, outside relative humidity, an idea about indoor air quality, which is the indoor air quality in your building. And right now we have carbon dioxide and TVOC, and you can see them for each HLR or for each cluster of HLRs. Thank you. That was my presentation. Thank you, Michael.
All right. Thank you, Marwa. It was a great overview of the HLR technology. Now, so as Marwa mentioned, that we had a project funded by the Department of Energy between NREL and Enverid to validate this technology in the field over the last several years. And so I'm going to cover the results of that project. So just to start out with what our test site criteria was, and this is important if you're considering adding this technology to your building. One thing is that you really need to understand what your outside air flow rates and your air balance in your building are, and because you're going to be reducing the outside air by closing your outside air dampers with this technology, and that's how you get your energy savings. But you need to make sure that there's enough reduction in that outside air available to offset so that you can realize those energy savings. So obviously, the dampers need to be operable, and they need to be controlled by the HLRs or through the HLR signals. And you need to make sure that you're able to maintain when you close down those outside air dampers, you're not closing them completely. You're just, because you still have to have some ventilation to balance your building with the exhaust in your building. So you want to make sure you're still maintaining a positive pressure in the building. And you want to make sure, obviously, that there's enough room for the HLR installation, which usually is not a problem. And then really for climate and hours of operation to achieve those energy savings, and we'll talk more about that in a moment. All right, so we considered multiple sites. These were all retrofit applications, and here's some pictures of some of those sites. We ended up deploying it at 6 sites, but we really only got performance data that we evaluated anyway from 2 of these sites, and some of the other sites I'll talk about, or one of the other sites I'll talk about was a very interesting project as well. It was very successful, but we were not able to validate performance because we didn't have a good baseline. But it's a good story, and I'll tell you about that in a moment. So the first site that I want to talk about is the University of Miami Wellness Center. This is a 60,000 square foot fitness and wellness center. It's on the upper floors above a parking garage, so it's actually pretty high above ground level, which helps a little bit with your outside air because you're not close to the roadways. However, this building is right next to very busy roads, so there are some concerns about outdoor air quality from that, and you certainly don't want to be breathing that in a wellness center if you're working out in there. But anyway, this building, when we went to this building, they had a lot of challenges with their ventilation because it was neglected, and especially in Miami, hot, humid climate, they tend to close down their outside air dampers often in the middle of the summer to control the humidity, because oftentimes they're just unable to meet the space conditioning requirements when it's hot and humid outside, and they have a lot of outside air, so they'll close down those outside air dampers, or they'll get rusted in place. You can't operate them. So this building, when we first got there, was was under pressurized, and it was sucking air in from the adjacent building, and they also had a small pool, which is a separate space, but they were sucking air from there, which obviously is not a good condition. So we fixed the dampers, got it back to normal operation, and installed 3 HLRs. We got data from summers of 2015, 2016, and 2017. Still, even when we were doing this operation, and for the monitoring and verification period, we did weekly on-off cycles. So a week on with the HLRs on, and a week off, and a week on, week off, so on. So we could collect data and compare performance. But we still had damper operation challenges, which kind of reduced our full data collection and introduced some uncertainty in some of the results. Second building I'm going to talk about is the Morgan Stanley headquarters building. It's in New York City. This is right on Times Square. It's a Class A office building, 42 stories, very large building. They installed 40 HLR units, so this is a much bigger installation. And these were plenum installations. So as Marwa talked about, you can't install these in a return air plenum, as seen in that picture. And then the air sucks. The HLRs take in the air from the return air plenum, treat it, and then put it back into the space, and then it's sucked it back in closer to the supply air, and then the exhaust will be exhausted outside. And then we collected data from 2017, again the weekly on-off cycle. We wanted to do a wintertime operation with this building. However, there were some challenges with pressurization of the exhaust, and they ended up having to add a supplemental fan to overcome that pressurization problem. And now it operates during the heating season. However, we're not able to collect that during the 2017-2018 winter. So the last building that we for this project was an office building in Fort Smith, Arkansas. It's the headquarters for ArcBest. It's a 5-story building, 190,000 square feet. This company experienced a lot of growth, and their occupancy was over the design occupancy by about 17%. And so they had challenges in meeting their ventilation and indoor air thermal comfort conditions with the existing HVAC system. And so they were looking at options and what to do. One option was to, add additional air handling unit and chiller capacity and boiler capacity. Or the second option was to install the HLR units. So 10 HLRs were installed. And what this did was it enabled them to reduce their outside air during, the summer and winter times, reducing that capacity on the HVAC system, so they're able to meet, we'll talk about the results, but they're able to meet those conditions and still operate effectively without expanding their HVAC system. So, results. The Wellness Center, as I said, we collected data from 3 summers, different results every summer. The first summer, the outside air damper for number 2 was stuck open, so we weren't able to see that full reduction in outside air, and we saw about a 10% chill water savings. In the second summer, we saw about 28% savings. In the last summer, almost 37% savings, and so it kept getting better. This was, again, just on the chilled water savings, not the whole HVAC system, but that's significant savings. Indoor air quality, everything looked good. There was a couple formaldehyde measurements that were slightly over, but I think since then all of those systems they've had no problems with formaldehyde, and CO2 levels were maintained below. I didn't put that on here, but they're maintained below the target CO2 levels. The Morgan Stanley building, again, we had a limited data collection period from mid-July through the end of September of 2017, and we saw about a 5% chill water savings. Now that doesn't sound as significant or as impressive as the Wellness Center, obviously, but this building is a very large building, very high chill water loads, and the main loads on this building for cooling are, because it's a very highly occupied building, and some of the floors operate 24/7 with a lot of computers and monitors and other internal equipment. And it's an all glass building in New York City. It has high envelope and internal loads, and ventilation is a smaller fraction of the overall cooling load. So we're starting with a smaller load to begin with, and then because of the limited data we had, and we had variable damper control during the different period during this session, so it increased some uncertainty in the results, and the temperatures during this period were not necessarily ideal because they were all over the place, and they actually probably worked against the HLR performance, the way that the temperatures turned out during this testing. The indoor air quality was very good, and one thing to notice too, the ozone, the particulate matter 2.5 and 10 were from outdoor sources, so they actually improved significantly during the testing because we were turning down the outside air, and also the HLRs helped remove the ozone and PM as well. So it improved indoor air quality during the operation of that system. The ArcBest headquarters building, again, this is the building that had an increased occupancy. So we couldn't really establish a baseline for energy savings because the existing system was unable to meet the IAQ requirements and temperature and humidity requirements, and so we couldn't really establish a valid baseline. But we were able to show that with the HLR operation, the system could meet all of the thermal requirements and the IAQ requirements, and they avoided this costly upgrade to the chilled water plant and the air handling units. And not only did they meet those requirements, they had fewer hot and cold calls and complaints about just the general indoor air quality itself. And they had significant energy and water savings. And then by, and this is the last bullet there, extending the life of the OA filters in the air handling units. This is true for all of the buildings because you're reducing your outside air intake, and so you're not putting as much loading on those outside air filters, so you don't have to change them as often. However, you will have obviously now the maintenance on the HLRs, so there's a little bit of a trade-off there. All right, just conclusions. We were able to show the HLR technology removes the gaseous contaminants from the air and allows for reduction in the OA. That's really the basic of it. And by reducing that OA, you get energy savings. But the energy savings, it's going to be highly dependent on how much you're able to reduce the OA, how long, so the hours of operation, and then the climate. So it's really best with long cooling or long heating seasons in those more hot and humid climates or cold climates, or these climates that have both pretty, in the Midwest, there's just a lot of hot, humid, and also heating climates in the winter. So it will operate in both in seasons and give you energy savings. It also potentially could work well with areas with poor outdoor air quality and help you improve your indoor air quality by reducing that OA ventilation need into your building. If you're going to put it in a retrofit application, it can work well, but you really have to know your OA flow rates and the air balance in your system and be able to control those things. So that's a challenge in a lot of existing buildings. Most buildings, maybe a dirty little secret, most buildings have poor ventilation and poor indoor air quality. But it's a challenge. This is challenging for buildings, for sure. All right, and for new construction, as Marwa mentioned earlier, you can, if for a properly designed systems, you should be able to reduce your capacity of your chiller and your air handling unit. So it should pay for the HLRs and still have savings on top of that. So it's a really good solution for new construction. All right, that's the last of my slides. If there are any questions, you can please type them into the chat window, or if you can also there's not too many people on the line. If you do want to speak, we can unmute you and
Michael, it looks like we have some questions in the questions box here. One question is from Carol, and it is, how long is the regeneration cycle? Doesn't that electric heating offset benefits?
Marwa,
I can answer that. So the regeneration cycle is about 1 hour. Basically the heater is for a 208 volt system is 5 kilowatt, and the fans are 300 watts. So if the fan works 10 hours during the day, that's 3 kilowatt. 1 hour for the regen, that's 5, so that's 8 kilowatt hour per day. So if you do the math based on the cost of energy you have, it's a very minuscule number compared to the energy savings.
And just from our monitoring, and then also from, we completed some energy modeling of this system, which I didn't talk about, but in the report, the regeneration and fan energy of the HLR is definitely more than offset by the energy savings from the chiller savings and heating savings in the wintertime. Great question. Anything else?
Yeah, we have a few that are popping up. The next question is, how about hospitals? Are they receptive?
I believe this question is about the HLR, right? About the inverted technology. So we cannot do in hospital spaces that follow standard 170. So we can do in areas that are outpatient care, like clinics, dentists. We can do because they follow standard 62.1, but we cannot do standard like spaces like hospital spaces. We cannot do because they follow a different standard, and basically they have also biological contaminants, and they require different amount of outside air that we cannot replace or reduce.
And then another question on here is, what is the maintenance on the HLRs and how much does it cost?
Yeah, so the maintenance, currently we have a yearly service contract that basically take care of replacing the cartridges. We call them a cartridge, inside the cartridge sorbent. And basically calibration of the sensors, updating software, and the 24/7 monitoring. It's around $2,000 per module. So $2,000 per module, and the module have 12 sorbent cartridges.
Next question is, what is the typical payback?
So I guess the question is from energy perspective, because we're not going to monetize indoor air quality. So the question is that from energy perspective, it really depends on the climate. It depends on what is the objective. Is it from energy savings or air quality? It also depends on the rebates available. To give you an idea, in our projects we did so far in New York, the payback is less than 3 years because we got very healthy rebates for retrofit. For plan and spec new construction, like Michael mentioned, if you decide to downsize your HVAC system, the payback is immediate because your cost of the HLRs will be offset by the cooling and heating equipment reduction.
Next question is, can this reduce smells like helicopter exhaust?
Yeah, that's a great question. Actually, we were looking at the project, and this back to the fact that outside air is not fresh anymore. To hospital spaces, again, we only look at clinics in these hospital spaces, where they basically have transient when the helicopter comes to the roof, and they have basically all the exhaust from the helicopter goes to their outside air. Similar also, you can talk about airports. So the system removes odor and also contaminants related basically to helicopter or like exhaust, transportation exhaust. It can deal with it basically.
And plus, you are reducing your outside air intake, so you'll be bringing in much less of that helicopter exhaust or truck exhaust from the outside air.
Next question is, how long does the absorbent cartridge last before replacement?
So our model now, it's 1 year. So it's 1 year from the installation to replacement.
Next, we have, what about pressure drop addition and cost for periodic replacement of cartridges? And that's a two-part question. Also, was savings based on after the optimization strategies for chillers have been implemented?
So for the pressure drop, we designed the system on purpose with fans to not add any pressure drop on the existing system. So we have the internal fans are capable of taking the air from the return air duct and putting it back to the return air duct, or taking it from a plenum, putting it back in a plenum. So on purpose, this was done that to have basically a self-sufficient box that can do that and can easily be retrofitted to not add pressure drop to the system. What was the second question?
The second was, it was also was savings based on after all the optimization strategies were implemented for chillers.
Yeah, so you can look at this easily, is that what the HLR does is it reduces the amount of outside air. And that it is, you know, in summary. So you are reducing the load on your cooling system or heating system. So if you have a better chiller, you can calculate the energy savings by putting a better efficiency. But still, it cuts the load. Now, if you have a very efficient chiller with a high COP or low kilowatt per ton, then your savings will be lower. We can do this calculation, you know, on specific project or like for specific climate, for specific outside air reduction.
Next is how many?
Sorry. Can I add just to that? The energy savings, as Marwa said, are pretty straightforward in that it's just you know, your reduction of outside air times your enthalpy difference between the outside air and that return air. So it's pretty straightforward calculation as far as energy savings.
Next, we have how many additional lead points does HLR provide?
Yeah, so that's a great question. So in March of 2018, USGBC issued a new pilot credit where it is about performance-based approaches. If you follow this pilot credit with the HLR, you can earn 6 to 7 points on behalf of indoor air quality credits, and up to 6 points on behalf of energy and atmosphere credits. And the reasoning behind this is that you can either follow the traditional approach and get maybe 30% plus outside air to your building and do an indoor air assessment, use low emitting material, or directly control outside air by control your indoor air by cleaning it and follow this performance-based approach. And then you earn credits on behalf of other existing credits. So again, it's 6 to 7 points on the IEQ section. And also you can claim energy. It's the only time you can claim energy efficiency by decreasing outside air. It's up to 6 points. Also depend on your system and your project.
Next, we have, is the performance of HLR time variant since the indoor pollutants are continuously removed by the source during the operation?
You can divide, to answer simply, you can divide the contaminants into two different sections. One section is carbon dioxide, which is removed or collected at parts per million, and other contaminants which are removed at parts per billion. So for the contaminants that are removed at parts per billion, like formaldehyde, benzene, styrene, etc., the performance is constant. For carbon dioxide, the performance vary during the time, and per design, you optimize your system, how many HLRs you need and how much outside air you reduced, based on understanding of the performance of the system, and also understanding how many units you need and doing regeneration at night. So basically, when you scrap carbon dioxide at parts per million level, it depends on your occupancy, it depends on your system, of course. But let's say you do one regeneration during the night and every day you start with the same efficiency. Specifically for carbon dioxide. The other contaminants, you have constant performance because you have, theoretically speaking, unlimited capacity to remove contaminants at parts per billion level.
Next question is, do you have a team that can help with design for retrofits? Is this a free service?
So we offer turnkey services, and our turnkey services basically we have everything from the design to permit to contractors, and we use most often is local contractors, local designers. We also have in-house designers and, based on contract designers.
Next is, I assume the equipment is plenum rated. Is that correct?
Is what? Can you repeat the question, please?
Plenum.
Yeah, so we have, we have the different ratings for the system. So yes, you are able to put it in a plenum. We already, obtained permitting and certification, and we have a lot of system and different configuration placed in the field. So we can, if you are interested, whoever asks this question, send me an email, and I can share with you a few case studies where we put the system in a plenum and how did we put it and how does it look.
Next is, what is the typical energy kilowatt savings per square feet?
It depends. It really depends on the climate in question and the specific projects. I know these metrics are nice to have, but it really depends on the projects. And usually, what we do is that if you go to our website, we have a takeoff sheet, and this takeoff sheet will basically you fill in the information, and we'll be happy to basically have an estimation of the project in question. So how many units versus how much outside air you want to keep. So typically, let me take a look here. Typically, we say typically the capex savings is between $20,000 to $40,000 per module for cooling. And heating is less than that, and then the annual savings is between $3,000 to $10,000 OPEX savings. But really depend on the climate and the project specifics.
Next question is, are all utilities giving rebates for this new technology?
So I can answer this question where we have installations. Basically, the utilities I mentioned in the presentations. We didn't do an effort to go to different territories than what we have installation yet and figure out the rebates. But in New York, Boston, Chicago, and a few places in Florida and in Texas, we obtained rebates based on our installation. In Arkansas, and as well in Tennessee.
Next is HLR solution offered in China and India?
So we have an office in China and we have a distributor in India. So we have our own presence in China and India. We have a distributor. So, but yeah, reach out to me and we can share more details.
And then the next is, when you do regeneration at night, nighttime purge, and thermal mass cooling may not be possible. Does this have any implications on energy savings?
So what we do is that 1 hour regen, it's a very low airflow. So the airflow during regeneration is only 300 CFM per module. I should have said that in the presentation. And you can able to schedule the regen to stagger the units. So not all the units will go regen at the same time. So if you do it at night, let's say from 10 to 11, you have ample time to cool the system before it goes again during the day. So there is no concern. There's no concern here. But also one advantage is that we can stagger the units. So if you have 10 units, you don't have to regen all of them at the same time.
We have one more question, Michael. Did you want to wrap up though, since it's 2 o'clock?
Well, go ahead and one more question, and then we'll end the.
Great. Last question is, how much does a module cost to purchase?
Okay, so can you reach out to us? So we have different reps in different territories. I can put you in the contact with basically the rep in your territory, and he can help you better.
Great, that's all questions.
Great, thank you all. And if please, again, reach out if you have any questions to myself or Marwa. And again, thank you, and we will be in touch.